Before we begin solving systems of equations using inverse matrices, let's look at the following. If we have a system of n linear equations and n variables, we can write it in matrix form. So we have the matrix A multiplied by the matrix X, and this is equal to the matrix B. Now A is known as the coefficient matrix, and X is known as the matrix of variables, and B is known as the matrix of constants. So please be sure to make a note of these. So now we want to isolate this matrix X, and we do that by removing this matrix A. So how do I remove the matrix A? Well, we simply multiply it by its inverse matrix. So you can see I've done that here, and I've applied this to both sides. Now you should recall that if I multiply a matrix by its inverse matrix, we end up with the identity matrix. So I'll simply replace these two here with the identity matrix. And then you should recall that if I multiply any matrix with the identity matrix, I'll end up with the same matrix. So I can replace this with X on the left hand side, or the matrix X on the left hand side. So we've isolated this matrix X, and it's equal to the inverse of the matrix A multiplied by the matrix B. Now before we begin to work through an example together, let's review the inverse of a 2 by 2 matrix. So over here we have the general formula to work out the inverse of an n by n matrix A. And this is equal to 1 over the determinant of A multiplied by the adjoint of the matrix A, where the determinant of A cannot equal 0. So we want to know how to calculate these for a 2 by 2 matrix. So if we have a 2 by 2 matrix A, where the elements are A, B, C, and D, then the determinant of A is A multiplied by D, take away B multiplied by C. So you can see here A multiplied by D, subtract B multiplied by C. Now, how do we work out the adjoint of the matrix A if it's a 2 by 2 matrix? Well, it's what we have over here. We simply swap these two elements around, so you can see the A and the D have been swapped. And then the B and the C elements, we will change the sign. Now that we have these two over here, we can simply substitute it into this general formula over here to give us the following. So if we have a 2 by 2 matrix A and we know the elements, we can simply substitute these elements into here to work out the inverse of that matrix. We have to be sure that the determinant of A cannot equal 0. So this part here, if it does equal 0, we can't find out the inverse. It doesn't have an inverse.
Now before we continue, please don't forget to like the video and subscribe to our channel. As a reminder, we offer private and group online math lessons on Zoom. The first session is always free. We cover all UAE National Curricula, American and British curriculums. We also have the best MSAT math test preparation course with a 50% discount for groups. So if you are interested in a free lesson, click the link in the description below and send us a message now. Okay, with that said, let's get back to our lesson.
So in this example, we're asked to use an inverse matrix to solve the system of equations if possible. So here is our system of equations. Now our first step is to write what we have here in matrix form, so AX equals B. Now if we recall, A is the coefficient matrix, so the coefficients here are 2, -1, 3 and 2, and I can write that down over here. X is our matrix of variables, so what are the variables? Well, there's simply X and Y, so I can write that down over here. And then B, so this is equal to B. B is the matrix of constants, so what are they? Well, we have the constants on the right hand side, 4 and 13, so I can write that down over here. And now we have it in the form AX equals B. So now this will allow us to solve for this matrix X. And if you recall earlier, the matrix X can be found by multiplying the inverse of the matrix A by the matrix B. Now, we know what the matrix B is. We need to find the inverse of the matrix A, and that's our second step. Now, if we recall, if we have a 2 by 2 matrix with elements A, B, C, D, the formula for the inverse matrix is as follows, where the determinant or the denominator here does not equal 0. So all we need to do is substitute the elements over here into here. So we have A, B, C and D, and we'll substitute them into this formula to give us the following. And then what we have here is a fraction, and this fraction will simplify to 1 over 7, and we're left with this matrix here, you can see. So this is our inverse matrix for A. So to continue this example, we had a system of equations, and for step 1 we wrote this in matrix form. And for step 2 we found the inverse of this matrix A over here. So for step 3 we simply need to find out the matrix X by multiplying the inverse of the matrix A, which we have over here, with the matrix B, which we know it's over here. So let's write this down. So we can see the matrix X, I've written X and Y over here. The inverse of the matrix A, I've written over here. And the matrix B, I've written over here. So now we need to multiply these two matrices together. So I'll do the working out for this over here. Now we have a 2 by 2 matrix multiplied by a 2 by 1 matrix. Now if we multiply these two correctly, we should end up with a 2 by 1 matrix. So we should end up with 2 rows and 1 column. So let's actually multiply these together. So we'll firstly do 2 multiplied by 4, and I'll write that down over here, plus the 1 multiplied by the 13, and I'll write that down over here. And then we'll do minus 3 multiplied by the 4, so I'll write that down over here, plus the 2 multiplied by 13, and I'll write that down over here. Now this here will simplify to 21 and 14, and you can see we have 2 rows and 1 column. So now all we need to do is multiply what we have in this matrix here by 1 over 7 to give us 3 and 2. So this matrix X is equivalent to, or is equal to, 3 and 2. So we know that X is equal to 3 and the Y is equal to 2, which I've written over here. So now that we've solved our system of equations and have our solution over here, step 4 is an important step, and it's often missed by students, and this is to check that your solutions hold true. So how do we do that? Well, let's look at the first equation, 2x minus y equals 4. We'll simply substitute these into the left-hand side, like so. And we want to know, does this equal the 4? Well, when we compute this, we get the answer 4, so we know that this holds true for this first equation. And then we have the second equation, 3x plus 2y equals 13, and we'll again substitute these values into the left-hand side over here, like so. And we want to know, does what we have over here equal 13? And it does indeed. So we know it holds true for both equations, and we know we're on the right path and we've worked out our answer correctly. So to summarize what we've learned so far, to solve a system of equations using inverse matrices, step 1 is to write the system in this form. So AX and B are all matrices. Step 2 is to find the inverse of matrix A. Step 3 is to multiply the inverse of matrix A by the matrix B. And step 4, and it's an important step, is to check your solution. Now it's your turn to have a go at answering these questions. So pause the video before I reveal the answers. And the answers are the following.